Your firewall is a crucial part of your privacy and security setup. You can think of it like a bouncer at a building, deciding who is allowed to enter and who is not.
Who are you? Got this order for a pizza to be delivered here to port 443? Looks like we're expecting you. Head on inside.
Thanks, dude.
Hold up, who are you?
I wanted to get to port 6.
They didn't call for that traffic.
Port 7?
You're not on my list.
Let's try 8.
Get lost, you are not getting in here.
The role of a basic firewall is to stop any unsolicited traffic.
Bren Cowing is the CEO of Protectly and an expert in home network security.
In most firewalls, anybody can leave to go out to the internet, but only specific traffic can come back. The firewall is the gatekeeper, and it is aware of any traffic that has gone out of the WAN interface, out to the internet, and it is going to let the response to that traffic come back. But any other unsolicited traffic, it's going to block.
It turns out that there is a lot of unsolicited traffic constantly bombarding our network and trying to get in.
And that's going to mostly be traffic from a variety of bots and other things that are out there that are just sending out traffic to seeing what responds. Because if it gets a response, that means that there's something on the other side of that. And that something on the other side might be exploitable. I would be willing to bet that the vast majority of any unsolicited traffic that's hitting your public IP address is in some way nefarious.
That's terrifying.
There's malicious actors out there doing it every single day. It is happening constantly. The good news is a standard firewall blocks the vast majority of that bad traffic.
Because the average firewall only lets in traffic that's been invited in. But even if it's traffic we're expecting, it could still be nefarious.
It's relatively easy these days to induce somebody to click a link in an email that looks authentic, that actually is going to a nefarious website that is hosting some sort of Trojan or malware. Because you specifically from inside your network requested that traffic, the firewall says, well, I guess it must be allowed and I'm going to let that back in.
This is where advanced firewalls like next generation firewalls come in handy, which are doing something called
deep packet inspection, which is diving deep into the packet and looking at the content of the packet to see if there's something that's bad in there.
Who are you?
I'm from IP address 104.19.129.108. You're definitely expecting me. See, I'm right there on your list.
You are, but I'm going to need you to empty your pockets.
Wait, what?
Sir, I need to know what's in your pockets.
God damn it.
Ho ho ho, would you look at that? Trying to sneak in malware. Not on my watch, buddy. Get out of here.
As well as using more advanced firewalls, you can also create completely separate networks and then create firewall rules to silo devices on these separate networks. What kinds of devices might you want to silo? Smart TVs, smart thermostats, home assistants. These are often referred to as Internet of Things or IoT devices because they're all connected to the internet. The idea is that they're meant to make your life easier, but they can also really hurt your privacy and security. Not only do they send back all kinds of data about your activities to their parent companies, but they're also notoriously insecure. But who cares if someone can hack my smart thermostat, right? So they might see what the temperature is. Big deal. Actually, it's much worse than that. Basically, if anyone can hack into one of these devices and gain access to your network, it puts all the devices on that network at risk.
If you want to have a device on your network that you want to have access to the internet, but you don't want it to access the other devices on your network, like your NAS or your computer, then you would put that on a segmented network. And on that network, you define your firewall rules to say, you can access the internet, but you cannot access your private LAN where all your private devices exist.
In this video, we'll show you how to create these rules so that you can silo all your IoT devices away from your more important devices. This is the second video in our series about home networks. In our first video, we explained how your router is actually really insecure, how there's better software and firmware that you should be using, and we taught you how to install these better systems. This video presumes that you've already gone through that process, set up pfSense on a Protectly Vault or similar device, and then created your first network on the LAN interface. And now we're going to create 2 more networks and set up firewall rules, siloing these networks from each other. But even if you don't have the same setup, this video will still teach you how to silo networks so that you can apply it to your own setup. If you're using a Protectly Vault, by default, the only interfaces that are enabled are WAN and LAN. So if we want to set up networks associated with these other 2 interfaces, we first have to enable them. We do that through our pfSense settings page, which in our last video, we set to be reachable at 192.168.137.1. Connect to your home network and type that into a browser. Then
log into pfSense and go to the interfaces.
in that drop-down menu, you'll see our two enabled interfaces, WAN and LAN, and the settings for enabling new interfaces, assignments. Click on Assignments. In these settings, the first two rows show the network ports assigned to the WAN and LAN. Click the Add button twice and it will automatically assign network ports to our OPT1 and OPT2 interfaces. Click Save, and you'll now see OPT1 and OPT2 listed in our drop-down interfaces menu. Now we're going to set up our OPT1 and OPT2 networks, which means assigning a static IP address to that network's gateway and setting up the DHCP range for that network. If you want to understand what all of this means, we explain it fully in the previous video in this series. In that video, we set up our LAN network in the 137 space. Because we now want to create a completely separate network, we're going to choose a different range of IP addresses for our OPT1 network. Click on the drop-down interfaces menu and select OPT1. Click Enable Interface at the top.
You want to set a static IPv4 configuration.
While usually devices are assigned a different random IP address each time they connect to your network, assigning a static IP address for our OPT1 interface means that you'll always be able to find the settings for this OPT1 network at the same address going forward. Now, what IP address should we choose for this network's gateway? We're already using the 137 space for our LAN network, meaning that 192.168.137.1 through to .254 are IP addresses reserved for devices on that network. If we want to now set up two completely separate networks, that means
the other networks you're going to want to set up in a different range.
You can choose any number from 0 to 255 for the third octet, as long as it's not 137. Let's go with 192.168.138.1 and 139.1 for our two new networks. Scroll to Static IPv4 configuration and under Address, write
the IP address of 192.168.138.1.
Next to that, there's a slash and then a number. Select 24. Under IPv4 upstream gateway, keep none.
Routers like pfSense are very well aware of the interfaces that exist within their own device. You don't have to choose your upstream gateway in this case because it already knows what the upstream gateway is.
You can ignore everything else and go ahead and click Save, and then click Apply Changes.
And that will enable the interface.
Now we'll follow the same general steps for our OPT2 network. Click on Interfaces and OPT2. Click Enable Interface. Under IPv4 configuration type, select Static IPv4. Under Static IPv4 configuration, type 192.168.139.1 as the address. Select /24. Save out and then select Apply Changes. Now we have to enable DHCP on these networks. DHCP is a service inside the pfSense software on our Vault that's in charge of handing out IP addresses to the network. To enable it, go to the drop-down Services menu, select DHCP Service, and then select the OPT1 tab. Check Enable DHCP Server on the OPT1 interface. And now you're going to fill in the range of numbers or IP addresses that DHCP is allowed to choose from when assigning IP addresses for that network. We're going to set our available ranges for both networks to 100 upwards for our fourth octet, and reserve the numbers lower than that for any other static IP addresses we might want to assign in the future. Under Range, for From, write 192.168.138.100, and for To, write 192.168.138.254. For DNS Server, write our gateway IP address, which is 192.168.138.1. Don't worry about the rest of the settings, just click Save. Now we'll set the range for our OPT2 network. Click on the OPT2 tab under DHCP Servers. Check Enable DHCP Server on the OPT2 interface. The range for OPT2 will be 192.168.139.100 in the From field and 192.168.139.254 in the To field. Under DNS Server, write the gateway address for your OPT2 network, which is 192.168.139.1, and click Save.
We have the interfaces enabled, we have the default gateway basically set up, and we have the DHCP service set up. The next thing that we need in order to access the internet is DNS.
DNS stands for the Domain Name System. It's like the phone book of the internet that allows you to connect to websites using domain names instead of IP addresses. It's the service that you use to translate these domain names into IP addresses so that your browser can load them. There's a DNS lookup service or DNS resolver on pfSense, which you can think of like a local copy of this phone book, and we're going to enable it. This will allow pfSense itself to resolve all of our DNS queries. Go to Services and select DNS Resolver. Scroll down to where it says Network Interfaces and select All. For outgoing network interfaces, select WAN. Click Save and then apply changes. Now, although pfSense has a cached or local copy of this internet phone book, it's not a complete list. In fact, many of the IP queries that we're going to make won't be found locally. So we also need what's called an upstream DNS service, which means one located on the internet. There are many to choose from. By default, our router usually uses the DNS service provided by our ISP, but this is a huge privacy issue. ISPs are notoriously bad for selling data, so if they know every single address or domain that you're visiting because it's looking up the IP addresses of everywhere you're going, that's a lot of information that you're giving them. In an upcoming video, we're going to fully dive into DNS and how to increase your privacy by choosing better settings.
We've enabled the interface. We've set an IP address for the interface. We've enabled DHCP server. We've told DHCP what the DNS address is for each of those networks, and we've even now enabled DNS servers on each of those networks.
Now it's time to dive into firewalls.
Because we have not enabled any of the firewall rules for those interfaces yet, all that traffic is going to get blocked.
Because by default, every firewall will block everything. We're going to first enable all traffic on each of our networks so that we can confirm that they can all reach the internet and that they're all in different IP spaces.
We'll just basically copy the firewall rule configuration from the LAN interface, and we'll implement it on OPT1 and OPT2, and we'll prove that those networks can then get out to the internet. Go to Firewall and go to Rules.
Then click on LAN and you'll see 3 different rules. The top one is an anti-lockout rule.
You've got it enabled on your LAN so that you can't configure something such that you block yourself from accessing the UI of the firewall.
And the bottom one is an IPv6 rule.
We don't have IPv6 enabled, so that doesn't matter.
The middle rule is what we're concerned about. It says under description, default allow LAN to any rule, which means that it's a rule that allows any device on the LAN network to access any other network. We're going to copy that using the button to the right that looks like a box. This duplicates the rule and takes you automatically to the settings for that duplicate.
Under interface, it'll say LAN, but you want to change that to OPT1. Then under source, it'll say LAN net, and you want to change that to be OPT1 net. Change the description to make it default allow OPT1 to any rule, and then hit save.
And apply the changes. We've just created a firewall rule for the OPT1 interface that says that devices on the OPT1 network are allowed to talk to devices on any other network. We're going to do the same thing for OPT2. Copy the rule. Under interface, select OPT2. Under source, select OPT2 net. And under description, write default allow OPT2 to any rule. Save and apply. Now let's test whether all our networks can access the internet and are in the correct IP range. Turn off your Wi-Fi, take a cable and plug it into OPT1 on one end and your computer on the other.
You want to verify that you get an OPT1 IP address.
That means something in the 138 space. You can verify this on Mac by going to System Preferences and on Windows by typing ipconfig/all into terminal.
You want to just try to get to bing.com or something. And verify that you can get there.
Now we're going to silo these networks. Because IoT devices like smart fridges and thermostats are notoriously insecure, they'll go on a different network.
We want to set up a network that's isolated from the network that's got your important devices on it. You can create firewall rules that will block access between these 2 different networks.
Here's how I'm going to use my 3 different networks. My LAN network, I'm going to make my normal network for everyday usage. My OPT2 network, I'm going to make my IoT network with a bunch of devices that I don't necessarily trust. And my OPT1 network, I'll make my most secure network, reserved just for storage or for more important devices. Devices on my OPT1 network will be able to initiate initiate contact with devices on any of my networks. LAN will be able to initiate contact with devices on OPT2, but not on OPT1, and my OPT2 network won't be able to initiate contact with either of my networks. So if any IoT device on OPT2 gets compromised and starts probing around to other networks, it will be blocked. Go to Firewall, Rules in the drop-down menu, and click on the LAN tab.
You want to create a firewall rule that will block traffic from LAN to OPT1.
Click Add. There are two add buttons, one with an up arrow and one with a down arrow. This will decide whether your rule goes at the top or the bottom.
The order of the rules is important. Firewall rules are executed in order. When a packet comes in, the firewall service compares it to the first rule. Does it match? No, go to the next one. Does it match? All the way down. If it gets to the very bottom and it hasn't matched any of the rules, it's going to get denied, dropped.
Add your rule using the up arrow, and it will immediately open the settings for that new rule.
The action is going to be a block rule. Interfaces LAN, your protocol will make this any. Source is LAN net. Destination is OPT1 net. Click on the log box.
This is going to log any attempts made by the devices on the LAN network to access our OPT1 network, which is helpful for knowing if there's anything fishy going on with our devices.
And then add a meaningful description so you know why you implemented this at some point later.
It should describe exactly what this firewall is doing. For example,
block traffic from LAN to OPT1. And hit save.
And apply your changes. It should show up in your rules list as a little cross, meaning it's a block rule.
It falls right underneath the anti-lockout rule. When the firewall now goes to evaluate the rules, it's going to match that rule before the rule below that, which is allow all that traffic. Adding the firewall rule above everything else enables that traffic to actually be blocked.
We currently have our computer connected to the OPT1 network in the 138 space, but if you look at the address we're on, it's in the 137 space, which is the LAN network. We've created rules saying that OPT1 can talk to the LAN network, which means that you should still be able to access this page. So refresh the page, and if it still works, then you've done things correctly. We also have a rule saying that the LAN network isn't allowed to try to access OPT1. To test whether this has been blocked like it should have been on another computer, let's call it computer 2, connect to your LAN network, i.e. the 137 space, open up terminal and type ping space 192.168.138.100, the IP address of my computer on the OPT1 network. You should see a bunch of request timeouts start to appear. In order to see whether our traffic is actually being blocked, we're going to take a look at our logs in pfSense. Go to Status in the drop-down menu and select System Logs. Then click the Firewall tab.
We want to turn on the dynamic view, which is going to refresh the list in real time.
Click the filter icon and under destination IP address, type 192.168.138.100, the IP address of my computer on the OPT1 network. We should see every ping request that computer 2 has just made, and it will tell us that these attempts for connection have been blocked.
What that means is that any device that's on the LAN interface cannot get to any device that's on the OPT1 interface. So now you can actually see what your firewall is doing in real time to make sure that traffic is permitted or denied according to the rules.
To stop the ping on computer 2, type Control-C. Now let's update our interface description to make sure that it's accurate.
Go back into interfaces and go to assignments. Click on OPT1 and under description, call it something that logically means this is my super safe private network.
You can also update your description of LAN to make sure it's clear that it's your everyday normal network, and update the description of OPT2 to say that it's your IoT network. Now we're going to create firewall rules for our OPT2 network, which will be for all of our IoT devices that we want to silo away from everything important.
OPT2 won't be able to get anywhere other than the internet.
Keep in mind there are multiple ways to build firewall rules. You can also use something called floating rules, but we're going to specifically create block rules on our OPT2 network. Click on Firewall, Rules, and then go to the OPT2 tab.
Because there's multiple destination networks that you want to prevent it from getting to, you would have to create two rules, one for each of those networks.
The first rule will block traffic from OPT2 to your LAN network. The second one will block traffic from OPT2 to your OPT1 network. As before, we already have a rule enabled on OPT2 that says allow to any, and we're going to supersede that rule by adding our new rules on top of it. So click Add with the up arrow.
Add a block rule. The interface OPT2 source is OPT2 net. Destination is OPT1 net.
For protocol, select any. Select log, add a description that describes the rule like blocking access to OPT1, save, and apply changes. Now we can copy that rule that we just created. In this second rule, interface stays the same as OPT2. Source also stays the same as OPT2. Destination is LAN net. For protocol, select any. Select log, and the description is blocking access to LAN. Save and apply changes. Now let's test it. Plug an Ethernet cable from OPT2 into your computer and try to access the internet. So OPT2 has internet.
Great, and now it should not be able to access your other devices.
You can test that by going to 192.168.137.1.
It should not work.
The page should just keep loading. So to recap our setup, we now have our normal network, the LAN network, set up in the 137 space, and that's where we do most of our activities and browsing. Then we have a more private network on OPT1, set up in the 138 space. And on this network, we keep more private devices. No other network is allowed to talk to these devices, but these devices can access anything on the other networks. We try to limit the amount of internet activity that we do on that network. Then we have our Internet of Things network on OPT2, set up in the 139 space. And on this network, we keep devices that are most dangerous to our network. So our smart thermostat, smart TV, etc. We want to silo these devices away from everything else so that they can't talk to anything. All of our devices can connect to this network, but nothing on this network is allowed to talk to other networks. If you want, you can add Wi-Fi to any of these networks.
If you have another old router kicking around, you could always use that as an access point on the other network.
Just put it in AP mode, which we show you how to do in our first video. Plug that wireless access point into your OPT1 or OPT2 interfaces and you'll have Wi-Fi access. You can also add a switch to any of these interfaces to give you more Ethernet ports. All devices on the switch will be able to talk freely with each other, but will only be able to communicate with other networks based on the rules that we just set up. And voila, segmenting our networks and setting up basic firewall rules is complete. Implementing these changes will give you a much more private and secure setup than before. In our next videos in this series, we'll go over DNS and further explain the privacy implications of that. We'll talk about deep packet inspection to make your firewalls more advanced, and we'll also talk about whole network VPNs. Your home network is key to the privacy and security of your online activity, so it's really worth taking the time to learn about how to make it more robust. Our free content is funded entirely by community donations, so if you're interested in supporting the work that we do, head to nbtv.media/support. Also, just liking, sharing, commenting on, and subscribing to this channel also really helps us. Thank you so much for watching.